Listen to part of a lecture in an earth science class.
Of course, you're all familiar with rainbows, perhaps the most beautiful of the atmospheric phenomena. However, there are other interesting but less common phenomena that I will be speaking about today. These are produced when light from the sun, or sometimes from the moon, passes through hexagonal-shaped or six-sided ice crystals. These ice crystals refract, that is, bend the light in the atmosphere. Imagine that the crystals are prisms bending each wavelength of light at a different angle. I want to describe three different phenomena that occur depending on the ice crystal's orientation towards the surface of the Earth. How the crystals are arranged in relation to the Earth. Okay, so the first phenomenon is a ring called a halo. This happens when the ice crystals are randomly scattered in the atmosphere. If the light enters these crystals, randomly scattered crystals, the light is dispersed around the sun or moon and is seen as a ring around the light source. So, halos occur when the ice crystals that the light shines through are randomly dispersed in the atmosphere. Okay. Sometimes, however, the ice crystals are oriented horizontally instead of randomly. Now, this causes a different phenomenon. If the sun is low in the sky and its light shines through horizontal ice crystals, we see two bright spots on either side of the sun. These are called sundogs and are seen at an angle of 22 degrees from the sun. Both halos and sundogs are caused by refraction of light. The third phenomenon is a sun pillar. Around sunrise or sunset, you might see a shaft of light stretching either upwards or downwards from the sun, a sun pillar. Unlike halos and sundogs, though, with sun pillars, sunlight reflects, not refracts, off horizontally aligned ice crystals that are gently falling through the atmosphere.
Using the information in the lecture, explain the three atmospheric phenomena that the lecturer discusses. The lecturer was talking about the three atmospheric phenomena that occur when light passes through six-sided ice crystals. The first phenomenon is a ring called halo. This happens when light goes through randomly scattered ice crystals in the atmosphere. Then the light is dispersed around the sun or the moon, and it can be seen as a ring around the sun or the moon. The second phenomenon can happen when the sun is low near the horizon, and its light goes through horizontally oriented ice crystals. Then two bright spots on either side of the sun appear. These spots are called sundogs. The third phenomenon is a sun pillar. It can happen around sunrise or sunset. Sun pillars look like a shaft of light, stretching either upwards or downwards from the sun. Halos and sundogs are caused by refraction of light, and sun pillars are caused by reflection of light.
Listen to part of a lecture in a music education class.
I'm sure you've heard of the Mozart Effect, a term coined to refer to the results of a neuroscience music brain experiment. In this experiment, researchers were looking at one specific area of the brain, where the ability to think in terms of space and time, or spatial temporal reasoning, takes place. This kind of reasoning is important in music, but not all aspects of music. And it's important in solving some types of physics and mathematics problems. Some types. The researchers chose Mozart's music because, as a child prodigy, he used space-time reasoning at an early age. I'm uncertain of the relationship between a child composer's use of this reasoning to create a masterpiece and an adult listener's use when hearing it. Anyway, the experimental group, college students, not children, were given a pretest just in their spatial temporal reasoning. Then they were divided into three groups. One heard no music, one a variety of different kinds of music, and one group only heard Mozart. Afterwards, all the subjects took an intelligence test. The results? Well, the Mozart group had increased scores on the spatial temporal reasoning section. The increase lasted for 10 minutes. Only 10 minutes. Now, there are several types of intelligence tests that could have been used, but only one type was used in the experiment. One wonders if a different IQ test would have had the same results. The study was interesting, but I'm concerned about the reaction of the general public. The media interest in the belief that listening to Mozart's music can increase one's intelligence was followed by "Help Your Child Be a Genius" books, popular magazine articles, and the flourishing market of videos, toys, and music products, all aimed at gullible parents. This is unfortunate because the real importance of music, that of bringing beauty into our lives, is being undermined by parents foolishly attempting to turn their children into rocket scientists.
Using points and examples from the lecture, explain how the experiment does not support the public's belief in the Mozart effect. The Mozart effect is a belief that listening to Mozart music can increase one's spatial temporal reasoning, which is important for solving some physics and mathematical problems. There was indeed one experiment on college students. Students were divided into 3 groups. The group that heard only Mozart had increased scores on the spatial temporal reasoning on the IQ test that they have taken afterwards. But that increase lasted only for 10 minutes, and only one type of IQ test was used. These results were interesting, but the media began to misinterpret the results, and soon a variety of useless products appeared. The sellers of those products claimed that the products will increase the children's IQ. Products were aimed at gullible parents. Those products are undermining the real importance of music, and that is bringing beauty into our lives.
Listen to part of a lecture in a cultural studies class.
Although the entertainment industry is concerned with telling a good story, it has had a profound effect on people's conceptions and misconceptions of the world around them. Let me give you an example. There are many films and TV programs in which a serious crime takes place and a police detective solves, or maybe doesn't solve, the crime. It appears that these fictional crimes, added to news reports of real crime, cause viewers' perception of the rate of criminal behavior to outrank, to exaggerate reality. In other words, the actual, let's say, murder rate is probably well below people's perception of the murder rate. I've just been talking about misconceptions of crime rates, but there are other misconceptions which may be more harmful. Now, I'm not saying that believing in an exaggerated level of criminality, say a high murder rate, isn't harmful. It could cause a lot of people undue stress, for example. But what I mean is misconceptions about race and gender stereotypes. A person of a different race or a female being typecast into certain roles. Think about, for example, the portrayal of a person in a wheelchair. He or she is either portrayed as overcoming incredible odds to do heroic deeds, or, on the other hand, being a helpless victim. Does this promote understanding or misconceptions? In the movies, doctors perform miracles, lawyers win cases, and crime scene investigators find the evidence. People in these actual professions often get clients with unreasonable expectations. Professional people comment that the reality of their daily routine, their job, is seldom like that portrayed in the media. Students are sometimes disillusioned about their career choice because the job seemed much more interesting in the television program than in reality. Unfortunately, we make these judgmental mistakes about our own society knowing full well the existence of the fantasy created by the media industry.
Using points and examples from the lecture, explain how the media has contributed to misconceptions about the real world. There are many examples how media has contributed to misconceptions about the real world. For example, there are many films in which a serious crime is committed. When those fictional crimes are added to news reports of real crimes, the rate of criminal behavior will be exaggerated. Furthermore, there are misconceptions about race and gender stereotypes. A person of a different race or a female being typecast into certain roles. In movies, doctors perform miracles, lawyers win cases, crime investigators solve crimes, while in reality that is not always the case. So people have unreasonable expectations from people in these professions. Students are sometimes disillusioned about their career choice, because the profession seemed much more interesting in the movie than in reality.
Listen to part of a lecture in an architecture class.
When planning a structure, engineers must consider the internal and external forces the structure must withstand. These are called loads. Broadly speaking, there are two types of loads: static and dynamic. Now, static loads concern those forces that don't change, and dynamic loads are those that change abruptly. First, let's look at static loads, which can be broken down into dead loads and live loads. Dead loads concern the weight distribution that the structure itself must bear. These would include beams, walls, floors, ceilings, and roofs. Calculating dead loads is quite straightforward. Now, live loads are those other weights that a structure must support. Live loads can be people, furniture, or, in the case of a bridge, cars and trucks. You may wonder why live loads like people or cars are considered static, since we move around all the time. Well, we can calculate how many people will fit into this classroom, say, or how many trucks can be on a bridge at the same time. Our comings and goings flow. They do not happen abruptly. Imagine that your family is sitting in different parts of a room and someone says, "Oh, look, northern lights." So everyone rushes to the same window to look outside. The live load changes from the weight being evenly distributed to its being concentrated at one point. Like dead loads, live load calculations can be computed. Now, remember that I said dynamic loads are those in which the forces change suddenly. For example, a gust of wind. Extreme examples of dynamic loads are tidal waves, hurricanes, or earthquakes. Think about earthquake zones. Here the engineer must consider features that allow the building to withstand, or let's say counteract, a sudden change of force, a force that is unpredictable.
Using points and examples from the lecture, explain the kinds of loads an engineer must consider when building a structure. There are two types of loads a structure must withstand: static loads and dynamic loads. Static loads encompass those forces that don't change, and dynamic loads are those that change abruptly. Static loads can be broken down into dead loads and live loads. Dead loads concern the weight distribution that the structure itself must bear. This includes beams, walls, floors, ceilings, and roofs. Calculating dead loads is straightforward. Live loads are those other weights that a structure must support, like furniture, people, or when it comes to bridges, cars, and trucks. Live loads do change over time, but they do not change abruptly. That is why live loads are considered to be static loads. On the other hand, dynamic loads are those in which the forces change suddenly. For example, a gust of wind, hurricanes, or earthquakes. An engineer must take dynamic loads into account, although these forces are unpredictable.
Listen to part of a lecture in a geology class.
Okay. Remember yesterday we talked about how rain containing carbon dioxide absorbed from the air and the soil forms a weak acid solution that soaks into the ground and in areas of limestone seeps along cracks in the limestone? The acid in the rain dissolves the limestone, and this forms caves and channels. So, over thousands of years, an area may become honeycombed with caverns and underground streams. Today, I want to go on to a particular feature of limestone terrain called the sinkhole. Sinkholes are hollows in the ground that can be from a few meters to several hundred meters deep. They are usually circular or oval in shape. In other words, a big hole in the ground. There are 3 different kinds of sinkholes, but right now I want to discuss perhaps the most dramatic, the collapse sinkhole. So how do sinkholes relate to the limestone caverns we were talking about yesterday? Now remember, we have the cave in the limestone. Well, sometimes the cave becomes too large and the roof becomes thinner and weaker. Eventually, the roof can no longer support the weight of the land above it and the water soaking into that land. So the roof of the cave gets weak and suddenly, bam, the roof collapses. Thus the name collapse sinkhole. Okay, so we can recognize this type of sinkhole by the steep sides formed by that sudden collapse. These sinkholes have become more common in recent years, mainly due to human activity, which often interferes with the natural flow of underground water. For example, we sometimes read in the newspaper about a house or section of road falling into a sinkhole when the roof of a cave collapses.
Using the information from the lecture, explain how a collapse sinkhole is formed. Sinkholes are hollows in the ground that can be from a few meters to several hundred meters deep. They are formed because rain absorbs carbon dioxide from the air and the soil. This forms a weak acid solution that soaks into the ground, and where there is limestone seeps along cracks in the limestone. This acid dissolves the limestone, and this forms channels and caves. The professor was talking about one particular type of sinkhole called the collapse sinkhole. This sinkhole is formed where there is a cave in the limestone. Sometimes the cave becomes too large and the roof becomes thinner and weaker. Eventually the roof can no longer support the weight of the land above it. It gets weak and suddenly the roof collapses, and therefore there is that name, collapse sinkhole.
Listen to part of a lecture in an earth science class.
When metals are mined or processed, fine particles of dust from these metals are dispersed into the atmosphere. In the areas around mines and metal processing facilities, the accumulation of these metals is considerable. Other metals get into the ground through rusting and corrosion of discarded objects at landfill sites and automobile scrap yards. And, of course, metals emitted by traffic also contribute to soil contamination. These metals remain in the ground for many years and negatively affect microorganisms by reducing their ability to break down plant matter. This prevents the release of nutrients from dead plants, thus lowering the fertility of the soil. Small amounts of metals get washed out or taken up by plants, and this in itself can be a problem. But much of the accumulation stays almost indefinitely in the ground. Over time, metal concentrations contribute to the loss of soil productivity. Contaminated soil has no life in it, and crop yields fall as a result. The metal cadmium, in particular, has become a problem in many places, since this metal is one component of artificial fertilizers. Now, as a result of widespread use of fertilizers, cadmium levels have increased gradually in arable soils, and also in cereal crops. If the levels of this and other metals reach critical levels, they can enter the food chain and pose a health risk to humans. Okay, now for the good news. The good news is that methods do exist for improving poisoned soil. Experiments have been carried out which show that certain plants have the ability to take up lead and cadmium into their root systems, decreasing the levels in the soil and eventually leading to improved soil and crop productivity. Nevertheless, it is important that constant monitoring of affected soil is performed so that such pollutants can be treated to reduce the harm they do.
Using the information in the lecture, describe the ways metals enter the soil and the way the lecturer suggests removing them. When metals are mined or processed, fine particles from these metals are dispersed into the atmosphere. This is particularly the case around mines and metal processing facilities. The soil contamination around these facilities is considerable. Metals also get into the soil through rusting of discarded objects at scrapyards. Also, metals emitted by traffic contribute to soil contamination. Also, many artificial fertilizers have high levels of cadmium in it. These metals negatively affect microorganisms in the ground by reducing their ability to break down plant matter. This lowers the fertility of the soil and may cause the loss of soil productivity. Methods do exist for curing the contaminated soil. Certain plants have the ability to take up lead and cadmium into their root system and eventually improve soil productivity.
Listen to part of a lecture in a physical education class.
Okay, back to training for those muscles used for jumping. Remember I said that it has been our experience that most athletes really give their leg muscles a good workout. The largest and strongest muscles in the body are in the hips, legs, and torso. These are the ones that give the most power to total body movements, so it makes sense. Unfortunately, many athletes tend to neglect their arm muscles. Arms are important when it comes to carrying through a jumping motion. So, as in working the legs, arm muscle training has several purposes. First, it reduces the athlete's risk of injury by strengthening muscles, bones, joints, and connective tissue. And second, the motions of the arms can increase the effectiveness of a jump. In other words, even if the arms aren't the actual muscles used in the jump, arm movement improves one's ability to perform the required jump. Okay, so remember that many sports require a large repertoire of jumping skills. In such sports, players must respond in a variety of ways to different situations that occur in the course of the game or activity. For example, think about a volleyball player making the next jump immediately after landing from one. Think of how that player uses his or her arms for balance and control, as well as returning the ball. Then, other sports require a highly specialized type of jumping, like the long jump or the hurdles, where the same kind of jump is repeated over and over again. To perfect these moves, an athlete has to repeat the motion, literally thousands of times, to ingrain its pattern into the subconscious memory of movement for not only the legs, but also the arms. This repetition strengthens the muscles so that the movement can be performed with less effort, more power, and often greater speed.
Using points and examples from the lecture, explain how arm movements are important in training for athletic jumps. Most athletes give their leg muscles a good workout, but also many athletes neglect their arm muscles. Arms are important when it comes to carrying through a jumping motion. Training of arm muscles has several purposes. First, it reduces the risk of injury by strengthening muscles, bones, joints, and connective tissue. Second, the motions of arms can increase the effectiveness of a jump. Furthermore, many sports require a large repertoire of jumping skills. For example, a volleyball player who is making the next jump immediately after landing from one. That player must use his arms for balance and control. Then there are other sports that require specialized types of jumping, like the long jump. An athlete must repeat the motions thousands of times to ingrain the movement pattern of his legs and arms into the subconscious memory. Thanks to repetition, movements can be performed with more power and less effort.